got interested in certain mathematical problems, and I was pursuing that. And then towards the end of my PhD, I got interested in some of the experimental aspects of optics. So then I was looking into that. And then after my PhD, I actually went into doing more biology-oriented problems. So, and today my major interest is looking at how to, how to apply physical principles in trying to understand some of the biological phenomena which you see in biology, in cell biology, for example. And so that at that point, I had actually left my biology at 10th standard. And then so I had to pick up many things because we need to talk to biologists. They speak a very different language from what people who are trained in physics teach. So when I started talking to some biologists, they told me that yes, we want physics people to come to biology and then do biology and using physics training. We don't want you to do physics here, but we want you to do biology. But we will value your physics training. So that is a kind of thing I was saying. And after all that, today I manage an institute and I have to solve a very completely different kind of problems, which have nothing to do with physics sometimes. Okay. And sometimes, it is something to do with construction related issues because you're building a large campus. Okay. And a lot of civil work going on. And I have to go supervise some of them. And I find that it's very easy for me to talk to the engineers, the civil engineers, and advise them and understand them. And I can really talk in terms because finally all of engineering is just physics application, right? Okay. So I'm able to do that quite comfortably. And in an IIT, we have all engineering branches here. And I find that even though I may not be able to go and do the nitty-gritty of what they do on a day-to-day basis, but I can understand broadly what they do. Okay? And that is definitely the advantage of having a physics training. So that is what I wanted to tell you, that that is why I'm telling you, I told you from the beginning that you have made a very good choice of deciding to pursue physics as your major in undergraduate education. At the same time, I'm telling you again that not to lose interest and not to leave other subjects, okay? Because you really don't know where you will find applications of physics is the most interesting thing is, right? Chemistry is all actually applied physics. And similarly in other branches too, okay, all of engineering, okay, and as I said, now as far as financial management or risk analysis goes, okay, there's a lot of application. So a lot of people actually think when they do physics, the technical physics, they think that once you've done physics, the only an academic career is there and nothing else. But that is not true at all. That's what I wanted to tell you. Okay. But then you have to develop other skills along with that. Okay. Along with your physics, along with your learning other subjects such as chemistry and mathematics, which you may have, you must learn other skills too. Okay. So a set of skill sets which you should have, like for example, computer programming, right? And that is something which you should pick up. And today you don't need to have a formal course. I don't know whether your course actually has computer programming, but even if you don't have it, you can just learn it on your own. There are so much material available on the web, and subject and programming languages like Python are pretty easy to learn. They are interpreted languages, and syntax is simple, and you can easy to learn. And there is a lot of tools available today, which helps you on freely available, which helps you helps you learn that. So I guess that is a very important thing, that computer programming and mathematics equally are something which you should develop. Okay. And your experimental skills, of course, is another one. Electronics, for example, okay, as very important in today's world. To have a good feel of electronics is very important. You might get into something which involves experiments, and every experiment today involves some level of computer programming and electronics, right? So, so that is also important. And whether you've gone into some manufacturing sector later, or that is, these are the skills which will become very helpful to you. So that is something which you can pick up on your own in today's world. That is not an issue at all. Okay, you can get so many material on the web, right? So and then you can pick them up and then learn. So that will also help you increase. That will also increase your value as a physics trained person who is able to code. And I can tell you, because especially in insisting on coding and experimental skills, because it has become very hard in today's world to find people who have this capability. I interact with a lot of companies who come in for recruitment in our campus, and also other ways around, some other contexts also, and also with the government's emphasis today on Atmanirbharta, and also on having startups and things like that. There are a lot of companies which started with high tech companies which are looking for people who have good skills, and it's very hard to find. And a lot of them are actually crying, saying that in this country you can't find somebody who can write 4-line code, who can understand a problem. So of course you can't do coding unless you understand the problem, right? Okay, knowing computer programming is one thing, but if you want to write a program for something, you also maybe should be able to understand what the problem you're writing is trying to solve is. Okay? And so that is also important, or that's more important. And so if you have done your physics courses and mathematics courses well, and if you have picked up some computer programming, okay, and if you have or if you have some good skills in on your experimental labs, in you have good hands-on skills, then you don't worry about your food, you will not go starving, right? Okay, you will definitely make it somewhere. Okay, and this is, I can tell you, there is can't be, if in this country, if you're talking about people who don't get jobs, and that is mainly because they lack skills. Just having a college degree is not enough. Nobody is going to give you a job based on a college degree. They look at what you have learned, right? And what is your capability, and what is your learning capability, and what is your skill set. Okay? So you should be able to say that when you go to an interview later. So in the essence, what I wanted to say is that what I wanted to break is that myth which a lot of people have, is that if you are learning physics or mathematics, then you only have an academic career, that you become a teacher, okay, or you become a scientist. That's not true. You can become a technologist, you can become a programmer, you can become a financial analyst. Okay, there are so many different opportunities available. So in that sense, I think you should be very happy. So that is one. And if you can learn, you know, uh, quantum mechanics, I think you should be able to learn anything. I mean, that's what my I'm not boasting, and I'm just saying that I'm not being arrogant, but that's a reality. Okay, because that is a confidence which you will get if you finish your uh, BSc or physics education correctly. You should, so that is very clear. Okay, you can very confidently say, okay, I don't know that, but I will be able to pick it up, right? And give me a few days. Okay, I will pick it up. And so that is what on the outset I wanted to tell you, okay, about the thing. And there is a lot of opportunities also in science if you're going on higher education and thing, right? Now, for those who want to now pursue higher education, there is a lot of opportunities again. Okay, I'm sure you will all write your jam and other things and go for masters. Some of you will go to for doing masters in physics. Where some of them maybe pursue masters in other areas, and there are a lot of opportunities there too. And physics will never go out of relevance because that's the way things are moving, right? It's getting more and more technology oriented, okay? And you will always need people with good physics understanding. And so research wise also, every research labs today would like to have physics people if you are good, if you're good at the subject. So learning fundamentals properly and able to solve problems, on your own, if post one is extremely important. You don't have to get, you don't have to get into very high level things at present, right? But get your basics correct. Okay, exactly. That has to be got correct. Okay, and your problem solving skills should be very good. Okay? And then you can reach any research labs in the future. So that I think that is what I wanted to just initially tell you. Okay, I then would like to actually take some questions, okay, and from you, and then have further discussion. And because I don't know really what you would like to know, right? So I can go on talking about this, but I would really like to know what is in your mind, what is your anxiety, okay, about your career, and then trying to answer that, those kind of things. Okay? Right. So let me pause here and take some questions, and then we can talk.
Ankur Shardar, you have raised your hand. Do you have any question? Please ask our research person.
Thank you, sir. Good evening, sir. Sir,
Good
I was
evening.
having some doubts about how much we have advanced in quantum mechanics in recent generation from the time it has actually started.
Sorry, sorry, I didn't get your question fully. Can you just repeat it?
Means, sir, in classical
Your voice
mechanics,
is not clear.
sir, is it fine now? Hello,
Yeah. Okay. Yeah.
sir. Means in
Yeah, I can hear you now. Yeah.
classical mechanics, we have studied about all the motions, and with the help of it, we also describe the planetary motions and other motion type objects. But when we go to into more smaller state, we are talking about quantum mechanics. But in with the help of quantum mechanics, we have certain theories like string theories which are still not proved. Means it is in a certain condition that right now we cannot prove them. Neither we can disprove them as well. So means how much actually uh, we are in a position with quantum mechanics. That is my question with respect to the development in classical mechanics, the comparison wise.
Yeah, so I don't know what how to answer that question, but just let me just tell you. I think so because quantum mechanics, now the major thing which is moving is of course there's a lot of thing about quantum computing area, right? Okay, so that is one area which and also quantum information theory. Okay, so that is the two very active areas today. Okay, string theory is not really quantum mechanics. Okay, string theory is something quite different. That's why you're saying it's not proven, etc. Because it's more like a mathematical aspect, right? Okay, so that is and it's not quantum mechanics as it is because it mostly deals with higher dimensions and things like that. Okay. So that is let's leave that aside. Okay, I'm not an expert to talk about that either. Uh, but in quantum mechanics today, two areas which is really very hot is one on quantum computing, that is quantum information theory. Okay, quantum information. Okay, because also because quantum cryptography also is important. Okay, so there is a lot of emphasis on this. In fact, I don't know even in our country there is a big project which is learned on quantum engineering. Okay, and which is trying to address these areas. Okay, because people do think that quantum computing will really become a reality, and it's a completely different. It's a paradigm changing thing on computing in the computing area. So it's a mixture of computer science, and so the area is a mixture of computer science, quantum mechanics, like physics people, right? And of course also electrical engineers. Okay, so it is that's why I'm saying that these things are getting very interdisciplinary today. Okay, so this is an area which where people work on a lot of things. And similarly in terms of quantum cryptography and quantum information, again people from electrical engineering like communication area, okay, and physicists work together, okay, looking at different aspects of it. So these are two areas which I can immediately think about in quantum mechanics, where people really think. Of course, there is other areas like devices and things like that. Okay, people, because even today computer chip, is getting smaller and smaller. Now people are talking about 7 nanometer, 5 nanometer ICs. Okay, so when that level, quantum mechanics becomes very important. Okay, and so those are there, but they are traditional areas. Okay, they are just getting more complicated, but more complex. But they are traditional areas. But the more emerging areas are these two, which I can think about now. Yeah,
Thank you, sir. May I ask one last question? Means from
please.
this part.
Yeah.
Sir, regarding the first half of the speech, you mentioned us about to gain as much as skills possible. But let us say I have learned a lots and lots of programming languages and other web development languages, or shall I say web development courses, and I have done all of those from free websites, searching on internet about all the data materials and everything, and learned everything by myself. How would I present those in the interviews for the companies? I mean, in
Oh,
my certificate it would be written that I've only passed out BSc or MSc
that's correct. Yeah, but
certificates.
but when you present your CV, right? When you present your CV, you will write your skills, right? You say that you have this skill, and you can, you're comfortable with whatever Java or comfortable with Python and coding, okay? And I'm saying just using a software skill is not very considered very good, but coding skill, okay, right? That you are able to write a code, okay? So then, if companies were interested, they will give you a problem to do and then ask you to code it, right? And then, that is, so they will know how to assess that. Okay, they will not really insist on a certificate. Okay, because you can of course get a certificate by paying somewhere. There are people who do certify. Okay, once you have learned everything on your own, that's fine. But then you can actually pay somewhere and get a certificate, and then take a test and then get a certificate. But that's not extremely important for getting a job, because if you write it in your CV that you have coding skills and you have learned all of those things, then they would test it for you. Yeah, they will test it definitely, because people are really looking for coding. People can code. Yeah, yeah,
Thank you, sir. It was really helpful.
yeah, yeah. Anybody else?
Students, if you have any questions or any queries, please ask.
Yeah, because because in jobs, getting job and is uh, definitely a major part of that is interview. Okay, so I guess like you must know how to present yourself, right? So your soft skill is also very important in that sense. Okay, it's important that how to present yourself and how you can talk to the interview committee, etc. Okay, so you don't be shy. Okay, ask any questions you want, and you should just get used to it. Asking questions, and nobody's going to judge you based on your questions. Okay, so so please ask. Okay, asking question is an important aspect of science, right? Uh, in fact, it's more important than answering questions. Okay? So asking question is also very important. So you can ask any question which you think you need an answer. Yeah, yeah.
Shuharthi and
Subrati.
Purushottam.
Yeah,
Yeah.
please.
Good evening, sir.
Good evening.
Sir, my question is that if we study in physics honors, can we go in AI technology in future?
Sorry, what is the last part you said?
I asked that if we study physics honors, can we go in AI technology in future?
Okay, yeah. So actually, I forgot to mention that. Thank you for asking that question. Yeah. So today you will hear this a lot. Okay, you will hear a lot about machine learning and artificial intelligence, right? Okay, and sometime back there was something called neural networks. Okay, right, and a lot of physicists were there in the neural networks. Okay, and in fact, that was a very when I was finishing my PhD, this was one of the hot topics, and a lot of people were getting into neural networks. And then neural networks, just as a theory thing, got lost its glory, and people went into more hard thing about analyzing, trying to understand human brain, right? How signals are done. So now, so that is one aspect of artificial intelligence. So, and then, so now that was one thing, and that is still going on. So that area, okay. So that is also a very emerging area. So I'll come to that a little later. Just to answer your question. So today, what we call about artificial intelligence and machine learning, okay, these are both together coupled, okay, is actually a very sophisticated way of applying statistics. Okay, right? So you have a lot of data. Okay, and now from that data, okay, you how do you so, and you have many models. Okay, now how do you know which model fits into what data, right? Okay, so in physics we always do modeling, right? The whole of physics is actually thing about modeling. Okay, so now you have learned modeling a lot. Okay, you have given a phenomena, and then you try to write a model for it, right? Okay, so now let's say you have two, three different models, and how do you know which model is the best? Okay, so then you try to get data about the phenomena, and then try to see which data fits your model very well. So now what people call as machine learning is actually some form of this. Okay, this is what it is. Okay? So now in machine learning, you have a model. Okay, and model has some tunable parameters. Okay, and then you have a lot of data. Okay, and then you try to get that data, and then see what is it the how these parameters can be fitted into that data, and then you use that model now to make predictions, right? Predictions about when new things come up. Okay, so this is what when we are looking at machine learning. Okay? So definitely, if you have done your statistics and statistical physics, and you are good at modeling, okay, and you will definitely you will find it very easy to get into the area of machine learning and artificial intelligence. Okay? So of course you need to know there is another aspect to AI, that is also the computer science side. Okay, so that is also you probably have to do. But as I said, like if you are good at math, then you can always pick that up. In fact, we have started in IIT Palakkad a data science program. Okay, an MTech in data science, and in that MTech program, we actually there are a couple of seats actually reserved for physics students. Okay. And because it's a data science is an interdisciplinary part, so we know everybody knows that. Okay, so we want people to come from different backgrounds. So those people, when they come in with the physics thing, of course they don't know many of the computer science aspect and some of the machine learning basics. Okay, so you give them those basic courses first. Okay, and then they do the more advanced courses later. Okay. And so because it's important to understand that machine learning and AI is actually for application. Okay, it is to be applied to different areas, right? Otherwise, it has no value. So it applied to different areas. So people use that in you must have heard about self-driving cars and things like that, right? Okay, so and so these are all applications of that. So you need to know some domain. Okay, it could be applied in it could be applied in mechanical engineering. It could be for controlling a whole manufacturing sector or something. Okay, or it could be applied in for safety kind of related things in some other engineering area. Okay? So it could be for road safety and train safety, various things, right? So safety or more efficient use of power, and whatever the area is, you need to understand that area also, right? Okay, and so it could be even looking at health sector. Okay, so you want to be able to predict. Okay, And if there is a new, like if of course, like a COVID kind of situation comes, okay, you should be able to predict which part of the country or which part of your state or district is more vulnerable. Okay, so if you have data on the health data of people, okay, on that area, okay, and where you know what their other comorbidities are, whether they have some other diseases and things like that, okay, and then and a new disease comes and people say, okay, this is people with this disease are already having, let's say, diabetes or something like that, okay, are more vulnerable to this particular new disease. So then if you have the data, you will be able to quickly analyze and tell, okay, this area, this particular region where there's more cases of this particular thing, illness, you have to be more careful. So now, in our country now, people have started collecting all this data. Okay, there is a lot of this data coming in. Okay, about health data for people and things like that. But we need to develop tools for that, right? So that is also part of the whole data science program. Okay, and so then you need people who understand how diseases spread, and things like that. And that is something which you learn in physics actually. Yeah, right? Yeah. So you would learn in statistical physics, you learn various things about models of how things spread on a network, and all of this kind of analysis also you do. So what I'm trying to say is that there is whole area of data science, not all of them, artificial intelligence and data science, where physics knowledge is important. Okay, and people will be looking for you for that. And your question about whether you will be able to learn it, of course, as I told you, my first part of the thing, right? And once you learn physics and you've learned the methods of physics and you have a good mathematical background and you know some programming, okay, you can learn anything, okay? And you'll be able to definitely do well in this area. Now, I also wanted to just this because you asked this question. Okay, I've also asked this question about AI and machine learning. It also reminded me about this whole thing about neural networks. Okay, and today that is also an area where the physics people work a lot. Okay, and many physics people again work with electrical engineers, which is to actually understand the neural networks. Okay, neural networks of the brain, not the theoretical neural network thing, but it is actually trying to understand how a brain functions. Okay? And so that is interesting because normally in engineering, they apply science, right? Physics fundamentals they have now applied, and that's how it become engineering, and that is what engineers normally do. Right? And now this neural network area, which in where now people are really trying to doing experiments on brain, okay, and trying to get networks how the brain connections are, okay, is an area where engineering models are used, okay, to get the science out. This is a reverse thing. Okay? And again, a lot of physicists work with electrical engineers, communication engineers, and electrical engineers who are doing communication thing, okay, to get those network models which they use in communication and trying to understand how the brain functions. And yeah, so this is an area which is also very upcoming and interesting for people. Yeah.
Thank you, sir.
Yeah.
Hello, sir.
Yeah, Purushottam. Yeah. Oh, Purushottam wanted to ask something, I thought.
Good morning. Good evening, sir.
Yeah, good evening.
Sir, I want to know, can I join ISRO or DRDO after completing BSc Physics?
I think they do take people after BSc also. They have different levels, but if you are going into an organization like ISRO or DRDO, it is best to go after masters. Yeah, because why I'm saying this is that yeah, at least a four-year BS program. Okay, if you have that, and because then you can always do your PhD later. Okay, but once you go after BSc into directly into such organizations and trying to get into enroll yourself into an MSc program or a master's program will become very difficult. Okay, in our country, we don't allow people to do PhD unless you have a master's or at least a four-year undergraduate degree. Okay, BS program is there nowadays, four-year BS program. The new national education policy recognized that as enough to do a PhD, but then you have to have that. Okay, so I wouldn't advise after a three-year program to go into ISRO, DRDO kind of research organizations, unless you not interested in further studies and going up in the thing and just you're going to stay in a technician level. Okay, yeah. So that's my understanding. Yes.
Okay, sir. Thank you, sir.
Yeah.
Hello, sir.
Yeah. Hello.
Good evening, sir.
Good evening.
Sir, this may be off topic, but there are some third year students of us present here today as well. So we will be appearing in some exams next year, like IIT JAM and JEST, and we are already preparing for it. Is there any advice you would like to give to us so that we can improve our preparation further?
Solve as many problems as possible. That's the only advice I can do. Okay, so when whatever material you can lay your hand on, okay, and solve as many problems as possible. Okay? And if you want to do well in jam, okay, that is a skill which you should have, and you have to. And unfortunately, these competitive exams are all like that. We people are looking at how many problems you can solve, right? And so that skill you should have, and that's only which I can tell you. Otherwise, you just focus on your BSc syllabus. Okay, don't go into very advanced books and things like that. Just keep your focus on the BSc syllabus, but apply. We develop the skill to apply it. Okay, which means that get as many problems as possible you can to solve and then solve them. Okay, and if you do that in a group, that's very very good, right? So yeah, so that's the main advice I have to give you. Because in jam also, actually, people, you must be knowing that if you can get 50% or above marks, then you're doing very well, extremely well. Okay, so in that sense, you don't have to worry too much. If you have developed understanding to apply whatever BSc level concepts you have learned, okay, into and able to solve problems. Math is also important. Yeah, mathematics also. Yeah. So right. So basically, if you're doing the problem solving skills, if you have, I think you have covered all of it. Right.
Okay, thank you, sir.
Yeah, and Shuman, you have something to ask?
Yes, sir. Good evening, sir.
Good evening.
Sir, in the very beginning of the lecture, you mentioned about the ability of guessing in physics. Sir, I want to know that if anybody want to discover principle or formulas in a branch of physics, can we choose the right physical phenomena as the base of the principle or the appropriate materials which can help us?
I don't know whether you were I don't think I have understood your question, and I did mention in the beginning of the lecture that physics kind of teaches you how to solve problems, right? Okay, how to.
Yes.
That is what I mentioned. Okay, I said physics teaches you a method of how to break down problems and how to a big question and then answer them, and two answerable questions, right? And smaller problems. Okay, so that I did mention. Okay, and. Yeah, but see, discovery, etc., are as a different thing. Okay, so there's a lot of creativity also involved in that. Okay, so it's very difficult to kind of give a formula for it, okay, and how you would finally come up with something new. Okay, that is definitely not a, a prescribed form. Otherwise, people will be discovering things, every day something, right? Okay, that doesn't happen. Okay, so it is, in research, what you basically are doing is to, trying to get a good understanding of whatever phenomena you're looking at, right? Okay, and then trying to break that down into smaller issues and then problems and then trying to solve them. That takes a long time to solve some of these things, right? Yeah. So for example, in my own research, I've been very much interested in looking at cell division, for example. Okay. And so trying, because people don't really understand cell division today. Okay? I'm talking about a biological cell, how it divide, right? Okay, and become two cells. And so you can just ask the question that how does it happen, and then just stare at it. That doesn't help you, right? So you look at experiments, and then you look at what are the experiments, what all you see, and then you look at what are the components involved, right, in the thing, okay, and what are the forces involved, okay, and then you try to write a model, right, and see whether this model, a simplistic model, okay, and then you look at whether how much this model can answer, okay, how much of the phenomena this model is able to capture, okay. And if the model is not able to capture any part of the phenomena, then you of course try to modify the model and look at it carefully. And that's why there's always this joke about physicists trying to solve considering a cow as a sphere, right? Okay, the problem of the spherical cow, people say, because that's the way physicists look at it. Okay, then when any problem comes, they look at the most simple case of it, right, and then build in complexity. So that is the method, okay, typically followed. Okay, and uh, of course, people might have, the problem you're looking at it. Some people must have already done the spherical curve part of it. Okay, that is, the simplest models are done. So you build on complexity on top of that. So that is how you go. Okay, so that is one method. I'm just saying that there is one method of doing that. Okay, looking at.
Okay, sir.
So yeah, so that is typically what is followed in physics. But discovery itself, there is no guarantee. Okay, finally you don't know whether you learn anything or you end up anything.
Yes, yes.
That's research. Yeah.
Okay, sir. Thank you.
Thank you. Yeah. Anybody else has anything to add? So how many of you in this group really want to pursue physics as a higher studies? That's very good.
Good evening, sir.
Yeah, that's yeah. Please.
Sir, my question is, what is the proper criteria to read a physics chapter?
Sorry, what is the
Sir, what should be a proper criteria to read a physics chapter?
physics? Like physics? What chapter?
Yes, sir. A topic or a chapter.
He maybe want to know that what is the actually procedure to learn the physics chapter. Maybe he want to.
Are you saying a new topic,
Yes.
right? So of course, yeah, reading is one. Okay, so I guess all of you would like to read things. Okay, so that, when you read one, but as I mentioned, I reiterate that again. In physics, I think finally you should be able to solve problems, right? So any new topic which you're picking up, okay, and you should find problems related to that, okay, and then solve them. If you are able to solve these problems, then you have actually understood the concept, okay, and that's the best test, because sometimes if you listen to a good lecture, in fact, if the lecturer is if your teacher is very skillful and very good speaker, okay, and the teacher tells something in the class, and then you probably would get fascinated by it, and you will probably think that you understood everything, okay, and this happens to whenever you have very good teachers, and you probably will think in the class that you have understood everything, And then later, when you try to pick up a problem and try to solve it, and then you will struggle. Okay, so that's so in that sense, the best way to you're answering your question. The best way to learn a new topic is to first you have to read, okay, and and also listen to lectures and things like that. Okay, but then you go into problems. You take the problem set, some problems, and then try to solve it. Okay? And that's the best. That's the best way to do it. Yes. Yeah. So I do see that a lot of you are interested in pursuing higher studies, and that is very, very good. Okay, I'm impressed. Okay. And so I have one thing to tell to all the people who want to pursue science in physics, into higher studies, into research and things like that, is that physics is also you know 20% inspiration and 80% perspiration. Okay, it is a lot of hard work. Okay, and it is not just about coming up with new things every day, or understanding a concept, etc., but you need to also do a lot of routine hard work. Okay, so the pen and paper calculations, or a keyboard usage for writing a computer code or whatever, okay, or doing an experiment and doing routine things in the lab, okay, and trying to solder things, or trying to make connections, or trying to write a interfacing code or whatever. Okay, a lot of work, a lot of things it involves. Okay, it might probably involves learning many other subjects also, like chemistry, for example. And so that is something which you should be prepared for. Okay, and you should not have romantic ideas about what the higher studies in science is. What? Okay, it is, if you're going to, especially going to research, it is a lot of hard work. Okay, and sometimes very routine things, extremely routine things. Okay, probably. Okay? So it might sound boring sometime, but but those are required, okay, if you want to really pursue and research and career. Yeah. So there are more questions here. No, sorry, I'll take them.
Sir, I have a question.
Yeah, please. Antanu.
Good evening, sir.
Good evening.
Sir, I want to learn about astrophysics in future. So,
Yeah.
sir, please tell me how can I get specialization in astrophysics after my BSc?
See, you specialization at what level? In BSc or MSc, or what are you saying, or in PhD?
MSc, sir, MSc,
Yeah,
and then PhD.
yeah. So you don't need to specialize in astrophysics in MSc level, or to go into PhD. Yeah. Okay. You see,
Okay, sir.
astrophysics. Yeah. So because you must really learn physics properly, right? Okay.
Yes,
So
sir.
yeah. So then astrophysics is basically you're applying the physical concepts which you have in the context of a phenomena which is happening in the space, right? So that is in the right. Okay. So so that's a phenomena you're looking at. Okay, there. Okay. But the tools you're using is what your basic physics is. Okay? So if anybody who wants to go to research, okay, uh, you learn the four pillars of physics correctly, okay, which is statistical mechanics, quantum mechanics, and classical mechanics, and electrodynamics, right? You learn that properly, okay, and get good mathematical skills, or good experimental skills, and computational skills. So if you have that, you can choose the area earlier later. Okay, but of course you do a lot of general reading, okay, and for that is for your interest, developing the interest, and also trying to understand where where the research is today in astrophysics. Okay? And you probably won't be able to research articles fully to understand the forefront of that, but you can always read more general science articles. Okay? And so that will tell you where you are. But to prepare yourself, you prepare your basics properly. That's all you need.
Thank you, sir.
Yeah.
Hello, sir.
Yeah. Subhrati?
Sir, my question is, how can I give my fully focus in my study in a continuous way?
How can you do that? You're asking me?
Yes, I think so. He is
Sir,
yeah, he is asking about how he can be focused in his study like this. Is it Subhradip?
Yes, yes, yes.
So what is distracting you? Huh? I'm sure your teachers would be I'm sure RK Mission the teachers would be able to tell you that much better than I am. Okay, so how to focus on your studies. I'm telling you again that like use pen and paper, please. Okay, science, hard sciences like physics is all about putting pen to paper. So you you write down things, you write down problems and try to solve them. Okay, and yeah, and if you have problem just reading and then writing things down. Okay, with your on pen and paper is the one way to focus on what you're doing, right? Okay, and I also said don't get uh, too much distracted by or too much too much in a hurry that you want to learn everything and you want to cover everything, etc. Whatever you have learning in your curriculum is enough. The concepts, that much concepts is enough for you to move ahead. Those concepts you should learn well and you should learn how to apply it. Okay, right? You don't have to learn too many things in that short time. Okay, and you uh, if you learn to apply it at those things, okay, and then that's and you will learn other things later whenever you want you pick up new things. Okay? Don't get anxious about it. Yeah. Yeah, so that's one thing. The two things only I can see about not having focus. One is that people get distracted by some other things. Okay, like maybe movies or whatever on the net, things like that. Okay, and that you should know to handle. And but other things, most common thing is that people who really very interested in science is that they want to look at too many things at the same time. Okay, and because they think that they should learn a lot of stuff before they get out of the BSc and things like that, and that is not required. So you focus. You can learn popular science, you can read popular science and other things just to get general feeling about things, but learning your fundamentals and which means that you know how to apply it. Right? So that is all you need to do at this point of time.
Thank you.
Yeah. Hello. Akash, you have something to ask? Or?
Hello.
Yes.
Hello.
Yeah, I can hear you.
Yes.
A lot of background noise, but I can still hear you.
You told us about you studied biological phenomenon after done your PhD in physics. So I want to know what in biology attract you uh, after doing PhD in physics to
Oh,
study it.
yeah. So this is a topic for a one full lecture. Okay, so I wouldn't get into that. I just tell you that like I just happened to listen to somebody who was talking about physics in biology, and I just got attracted to it because I thought I had some skill at that point of time to solve one of the things which he was talking about. Okay, and so I got when I went into the postdoctoral thing to pick up that thing. So that is a thing, and in fact the reason is that there is biology was a very descriptive science before, right? And and people are now moving into what you call quantitative biology, where people want to really now understand things quantitatively and also make it into a hard science which is based on models. Okay, and so that this has more predictive power and things like that. So earlier The physics contribution to biology was only in terms of tools, okay, like microscopy and like analyzing things, etc. That was a or X-ray, right? These are all people who did biophysics. These are the kind of things they are done earlier. But now people are getting more into physics. There is a whole set of very fascinating phenomena in biology, which is no understanding. If you read a typical biology book, you think all problems are solved, but then if you read it carefully, you will see that they are all descriptive, okay, and very very descriptive, okay, and there is no real understanding. People do understand what are the different players, different molecular players in different phenomena like cell division, which as I said, or cell communication, okay, or even neural connections, etc. People do understand a lot about what are the different players involved, what are the molecules there which are doing these things, but they don't really understand how they are doing it. Right? So there are a whole lot of issues, lots and lots of problems there. In that sense, I thought there's a new area where I can look at a lot of problems than getting into a very matured area where you have to really hunt deep into going to a problem. So that was my interest in it, okay, and it continues, and there's still a lot of people getting into it. But of course, you have to work with biologists if you want to do something meaningful. Otherwise, it becomes just a physics modeling exercise.
Thank you, sir.
Sir, I think more than 1 hour you have passed with us. You are tired now. Student, when actually student, the student immediately first time they could not open their mouth. Then,
Yeah,
then you are a good teacher. Many students start questions now. Sir, actually, sir, we are very happy. Sir, in future, we are touch with you, sir. When you come Kolkata, sir, please actually miss call me. I arrange
please.
your visit. Sir,
Sure.
our ex-student of our college in chemistry, Sadhukha, that
Oh,
is actually
okay. Shushabat.
he chemistry. He is our ex-student of our
Yeah.
college.
Oh, Shushabat.
Sushopan
Yeah.
Sadhuka.
Yeah, I know.
Sushopan Sadhuka. He is our chemistry department ex-student, sir.
Yeah. Oh, very good.
So our linkage with your institute also very old is with.
Very good.
So
Yeah.
yes, sir, yes, sir. So
I,
I very much delighted you so nicely interact with the small children. No, it is a very pleasure to me to hear with you your actually talk and also. So,
thank you very
so I
much.
request. So I request actually our faculty members. So Paula sir, you may be vote of thanks. Now give.
Yes,
You
yes,
give.
I
Yes,
am.
please give the vote of thanks.
Okay. So on behalf of the Ramakrishna Mission Vivekananda Centenary College, I extend a hearty vote of thanks to our honorable resource person, Professor P.B. Sunil Kumar, actually who spared his time from his very busy schedule in this induction program. And I hope his talk will really helpful to our students for their future perspectives. I extend my thanks to Honorable Principal Swami Kamalasthananda Maharaj for arranging such an enlightening induction program. And I extend my thanks to Swami Vedanuragananda Maharaj. I am immensely thankful to all of our faculty members of the Department of Physics to make this event a successful one. And finally, I would like to thank our young friends, the students of our Department of Physics, for their presence and very interaction in this event with our honorable resource person, Professor Sunil Kumar. Thank you to all of you present here. Thank you.
Thank you. Thank you very much. Thank you. Bye.
Yes, sir. Yes, sir. In future also, physically we want
Yeah,
to
I will
visit.
come. I will come. Yeah.
Yes,
It
sir.
was,
Yes, sir.
it was very
Oh,
nice talking to all the students, and they were
yes,
very,
sir.
very
Yes, sir.
interactive. I like that. Like,
When you come physically, then student and teacher will be very delighted, sir,
sure.
to see you, sir.
I will definitely come. I would love to.
Yes, sir.
Yeah?
Sir, namaste, sir.
All right.
Namaste, sir. Namaste.
Thank you.
Good night to all of you.
Good night, sir.
Good night, sir.
Good night, sir.
Good night, all of you.